Okay, so in this problem, I'm given grams, I'm given liters, and I want pH. I can think about it two ways. I can think about that if I know I want pH, the easiest way to calculate that is using this formula, which means I need to find my molarity of my H+. Molarity is moles over liters, and grams can help me get to moles because I have liters. So you can start at what they're asking for to kind of think through the process, or if you want to just ignore all that, I know I have grams. What's something I can do with grams? Find moles. Grams equals moles times molecular weight. The grams are of HCl, so I need to use the molecular weight of HCl. 16.1 divided by 36.5. For my moles, I get my moles to be 0.44. Now, I would encourage you to say moles of what? Well, this grams was of HCl, so this moles is of HCl. Then I can find the molarity of my HCl by taking my moles and dividing it by my liters. And my molarity of my HCl is 0.055. Molarity is brackets. So what I have here is the HCl molarity. My formula doesn't say HCl, so what I need to know is that this is equal to my H+, because of that 1-to-1 ratio we talked about. So this would be sufficient in terms of showing enough work as far as I'm concerned. If you want to see where it comes from dissociating HCl, taking the HCl molarity and multiplying by what we want, which is H+, over what we have, which is HCl. There's that 1-to-1. And I would get 0.055 as my H+ molarity. So you can either, this is what's actually happening, what I just circled. If you want to show it like this, as long as you understand where it's coming from, and you're writing that 1-to-1, I'm good with that too. So again, I had to do that because the value I had was of HCl. My formula for pH does not have HCl in it, it just has H+. So to finally find my pH, which is what they want, I would plug in my calculator, negative log of 0.055. And I would get 1.26. Always giving 2 decimals for pH values.